طيب بسم الله الرحمن الرحيم. I know this looks kind of messy, but I will try to introduce you to our training equipment here that we'll be using during the rest of the semester, inshallah. So basically, this process station, as you can see here, the first page of the manual talks about the RT578 trainer that is designed by Gunt Hamburg. This is really a masterpiece, to say the least. You see, in this one integrated process stations, we have a variety of process equipment, instruments, and a control system that can be designed to operate our process equipment, whether locally from this panel right here, or remotely using the software available here on the PC. So this device has been designed basically to control mainly 4 process variables, and those variables are, as you can see here, level, flow rate, pressure, and temperature. Okay. There are also 2 different control strategies that can be implemented. The first one is the continuous feedback control and the cascade control, as you can see here. So the training manual that we have at the moment covers only the 4 basic experiments, which are the feedback control for level, flow rate, pressure, and temperature. And inshallah, I will try my best by the end of this semester to show you how the cascade control works in principle. What is really brilliant about this process station, gentlemen, is that for the control strategy, we have the luxury of choosing our final control element to be either the pump, which is, by the way, this pump right here. It's a centrifugal vertical multi-stage pump. Basically, it has 6 stages, meaning that you have 1 common shaft and 6 inputs. So that is a little bit different from what you have studied in process equipment, where you have only 1 impeller. This pump right here has 6 impellers instead of 1. The other actuator or final control element that we can utilize to control our process variables in here is the automatic control valve. So that is different from the manual valves that we have in here as well. This valve opens and closes automatically based on a pneumatic signal that is provided from here as well. So we have a compressed air supply from here, and it flows through the hose. We have a pressure regulator here, and you'll see, inshallah, that for safety purposes we have to maintain the pressure here at a value not exceeding 2 bars. And we have, based on the values that will be sent, or that will be set here on the controller, whether it is the remote or the local controller, the valve automatically opens and closes. Right. Now, the basic principle is that we have piping connections, so many process equipment. Talking about pumps, so we have 2 pumps. This is the first one, and this is the second one. We have tanks, heaters. We have another tank right here. Okay. Everything looks so connected and complicated. Well, guys, in order to understand how each experiment is going to be set, the thing that we need to look at is basically what is called the process flow diagram. This process flow diagram that you have in your training manual explains how process equipment are connected to each other. And the experimental procedures will determine based on switching on or off one or two of the equipment, opening and closing some of the valves will determine which particular experiment is to be conducted. طبعا, in addition to the process equipment that we have a variety of measuring elements or sensors. We have direct measurements, direct local measurements, like the pressure gauges that we have. We have a pressure gauge here that measures the discharge pressure of the pump. We have some temperature gauges, measure the inlet and outlet temperature from this heat exchanger. We also have what is known as a level transducer, and inshallah we'll try to explain what is the main difference between the sensor and transducer. Okay. We have also this temperature gauge right here, and we have this what is called the magnetic flow meter that measures water flow rates. Okay. Now, as I said, guys, we have, with this brilliant piece of equipment, we have the luxury of controlling and monitoring our process once we start it up. Okay, and that can be done. The modern practice is that most of the control systems have been designed to control the process remotely from a control room. So that would kind of serve as our control room, guys, where we have to monitor our process variables. Okay, so in this interface we have to select which experiment or which variable is to be controlled. So let's say, for example, guys, that I want to control the water flow rate in the process. So I'm going to select water flow rates, and the actuator in here, guys, or the final control element, which is the piece of equipment that we have the ability to change its position in order to manipulate one of the process variables. So last week we talked about the types of process variables we have in the system, and one of them is the manipulated variable, guys. And we said that the manipulated variable is a variable that we have the ability to adjust its value so the control variable will be maintained at the desired set point. Okay, so in this example, because I don't want really to use the automatic control valve, it sounds a little bit noisy, so I'm going to select the pump here as my actuator. So as you can see here, guys, we have pump P1 as the actuator. So we have the process flow diagram in here, guys, and that's how the system works. We have a sensor that measures water flow rates. We're going to talk about how this magnetic flow meter is designed and how it measures water flow rates. Now the signal will be sent, guys, from this sensor to the controller. We talked about the types of signals that we have in control systems. Now inside here, guys, we have the controller. Now for the controller, gentlemen, usually we have two scenarios. First of all, if you are going to start up, shut down, or you might have a problem with your automatic control system, you would have to control the process manually. Right? Now when you talk about manual control, I'm trying to say here that in the manual control, the brain of the system or the computer of the system, who is going to compare the current measured value, as you can see, guys, this is the current measured value, or you can see it right here, with the reference set point. Okay, this is the set point that we have, guys, and based on the comparison, gentlemen, we will adjust the signal that will go from the controller to the final control element. Okay, so let me give you an example here. The system is operating right now. I'm controlling the process manually, and inshallah later on, when we follow the experimental procedure, we can switch to the automatic control. Now, I'm receiving a signal from the flow meter telling me that the current measured value of my control variable is around 36.8%. And the set point, guys, as you can see here, is around 10%. So I have to make the calculations. So there is about 26% error or difference. Based on that, I'm going to have to adjust the controller output signal. So what I'm going to do here, Shabab, is that I'm going to change the signal that will go to the manipulated variable. So if I go down to 15%, before that, Shabab, let's try to look at the measured flow rate. It's around 1,500. Now the pump is my final control element. So if I go down from 20 to 15%, you're going to notice that the measured value right now is going down to around 32. Okay, the flow rate previously was around 1,500. Now it's around 1,300. When I made this change in the output signal, what happened exactly is that the output signal going from the controller, as you can see here, to the final control element, which is the pump, has been changed. I reduced the value of the output signal. So it's like telling the pump to reduce its speed. By the way, guys, this is a variable speed pump, which means you have the ability to change the impeller speed. Okay, so you will see in some of the industry applications that in order to control the flow rates, you have a fixed speed pump and a control valve to control the flow rate by opening and closing the valve. Some other flow control systems, instead of using the control valve, they use only a variable speed pump. Okay. Now I can further, Shabab, after the change, I can further do the calculations. 32 minus 10, that makes a 22% error. So I'm going to go down and reduce it to, let's say, 5%. Okay, so you will see that the measured value right now has started to decrease. And if you look at the measured flow rate right now, it was 1,300. Now it's around 900 and something. So, inshallah, for the training manual, gentlemen, we will start with the flow rates. Okay. And as you can see here, guys, we have this process flow diagram with a table that shows the name of each process equipment based on the tag of the equipment. And in addition to that, there are some precautions that need to be taken in order to clean up the system, make sure that the pump will not cavitate. As you remember, in process equipment, centrifugal pumps are might experience cavitation, so there is some kind of a procedure to prevent that. And inshallah, we will talk about the next week. Inshallah, we will talk about our first experiment, which is the flow rate control. Okay? So whenever you or before you conduct an experiment, you would have to read about the theory of the experiment. Number two, read the process description, which is available in every experiment. Have a look at the experimental procedure before that. So inshallah, when you come to the lab, you are limited only with 1 hour. So when you come to the lab, inshallah, we will be able to conduct the experiment, take readings, have a brief discussion before we finish, and introduce the second group. I wish you all the best, inshallah. I know that I'm making this video from my own phone. It doesn't look really organized, but hopefully, inshallah, you will understand, or at least you will have basic understanding of how the system works.